Alright, this is Mr. Gillum, and today what we're going to do is we're going to do our final little truth tables day and learn about biconditionals. Sounds insane, but it's not too bad. Really, we know what a conditional is, and now today I'm going to introduce you to a biconditional and how those truth tables work. So basically what a biconditional is when you have a conditional, like an if-then statement, and it's true, and then you have its biconditional, and you have its converse, and it is true, then we can call that a biconditional. We're going to squeeze the original conditional statement with its converse, squeeze it all together in one, and we're going to call it an if and only if statement. Okay, if and only if. Okay, and it looks like I have emphasized that right here. The format goes the hypothesis right here. If and only if, instead of saying if, hypothesis, then conclusion. Now we're doing the hypothesis, if and only if, then the conclusion over here. Alright, and kind of like a conditional where we had the arrow as a symbol. Now for the biconditional, we're going to have an arrow going both directions, because a biconditional is an if-then statement that is true both forwards and backwards, or false both forwards and backwards. All right, and we're going to have some specific examples of exactly what a biconditional is right now. So if I had this conditional and it said if you entered the right password, then you access your account. Okay, that's a conditional. It's just an if-then statement. Its converse would be if you access your account. So if I switch these around, then I get this statement down here. If you access your account, then you entered the correct password. Now those things are dependent on one another. No matter what, if you enter the right password, you'll get in your account. No matter what, if you get in your account, then you had to have entered the right password. So we could say you entered the right password if and only if you access your account. Now, a little different about biconditionals and conditionals. It kind of works the same way as well if the statements are false. If you didn't enter the right password, you did not enter your account. So the negation of a biconditional, if those statements are false, if one is false, they are both false, no matter what. Okay. Yeah, let's take a look at another one here. It says rewrite the biconditional statement as a conditional statement and its converse. So now we're going backwards. We're starting with our biconditional. It says a number is a perfect square if and only if, so that indicates that we're doing a biconditional. It is the product of some number times itself. Now let's think about this. If we separate it into its first conditional, a number is a perfect square if a number is a perfect square, then the product of the number, then it is the product of the number times itself. That is true. If I flip-flop them and put the conclusion first and the hypothesis second, if the product, so let's do this part, if the product of some number times itself, then a number is a perfect square. That is also true. Alright, so it can be flip-flopped back and forth on a biconditional. Alright, they are dependent on one another being true. So either they are both true or they are both false. Okay, one specifically determines the next. But they can be flip-flopped, so we call it a biconditional. Alright, let's take a look at this next one here. And it says two angles are complementary if and only if their sum is 90 degrees. If and only if represents a biconditional statement, and we're going to separate it into two conditionals, two if-then statements. If two angles are complementary, then their sum is 90 degrees. Or we could say, if we had the converse here, if their sum is 90 degrees, then the two angles are complementary. So as you see here, either of these is true, no matter which way you write it. So this is in fact a legitimate biconditional. Okay, no matter what we do, no matter which order we put it in. Okay, so our two if-then statements are going to get squished together into a biconditional, and it's going to be true as well. It says, consider the given statements to decide if it is a biconditional statement and if it is true. Well, to determine if it's a biconditional statement, all we're looking for really is the if and only if. So that much we know is true. So yes, this one is a biconditional. However, when we're deciding the truthfulness of this biconditional, we need to think of two things. First of all, we need to think, okay, if it is raining, then there are clouds in the sky. Okay, that's true. That's true enough. We can say that's true. However, when I look at the converse and I say, if there are clouds in the sky, then it is raining. That is not true. Okay, there can be times where there's clouds in the sky and it's not raining. So yes, it is a biconditional. It does use if and only if. However, it's not a true biconditional. It can be cloudy out and not raining, so it's not true. Okay, so it's not a good biconditional. It's a false biconditional. So let's look at this one. It says two angles are adjacent angles. Okay, so just a reminder on what an adjacent angle is. If I had this angle and a bisector right here, we call this guy angle A and this guy angle B. Those would be adjacent because they share a vertex and they share actually a side. So this biconditional says two angles are adjacent angles if and only if. So okay, that tells me that it is a biconditional. They share a vertex and one side but do not have any common interior points. Okay, now if two angles are adjacent angles, so if I change this first part, then they share a vertex on one side. That is true. I'm not going to write that whole sentence out, but that is true. And then if I flip it around for the converse, if the angles share a vertex in one side, they do not have any common interior points, then two angles are adjacent. That is true as well. So I'll just do it this way. P then Q, that is true. Q then P, that is true as well. Therefore, it is a good biconditional. It has the if and only if format, and sometimes that is, by the way, that's abbreviated IFF, if and only if. Q then P, that is true as well. All right, I just want to look at one last truth table here, just to get you an idea of how the biconditional is going to work in a truth table. Well, I guess we're gonna explain how the if-then statements are gonna work. Okay, so we're gonna set up our truth table like we have been in the past, and I really should have on your notes. You should put this in as well. I should really have parentheses around these because we're saying if P then Q and if Q then P. That is literally what a biconditional is. Both have to be true, exactly true. So let's take a look here. We got our P, we need a Q, and we need each if-then statement, and then finally the conjunction here, if P then Q. So let's just see. We're going to start our table like we normally do. True, false. And then, okay, if then. So I'm looking for the one instance where if then is not true. It's when it's a true and then a false. And that's what we practiced yesterday. So I know this is a false, but all other statements are true. If Q then P, now remember we're going backwards, so true to true, false to true, that's okay. True to false, this one is actually the one that's going to be false. All right, that's actually going to be the false one right there, because Q is representing our hypotenuse and P is representing our conclusion, so we actually need to go from Q to P. And if it goes from true to false, then it's false. And then everything else is good to go. Now I'm looking at, and those aren't very clear in there, put those on there. Okay, now we should look at these two columns right here, this guy and this guy. And we're good as long as it's true to true. True to true is good, false to true is okay, true to false is false, and true to true is true. Okay. Uh-oh, wait, whoa, that's not quite right. Silly me. We have an and statement, much different. It has to both be true, and if one of them is false, it is not true at all. Sorry about that. Got a little confused there. And conjunction. That's what I get for pushing pause in the middle of my video. Okay, so there we go. Now we have this nice truth table here. True, false, false, true. And that is actually the truth table of a biconditional. Because if P then Q and if Q then P, then therefore if and only if is how we're going to write it. And it's going to be a biconditional. So here's how it works. We got true, true, false, false, true, false, true, false. If they are both true, we know it is true. If they are both false, we know it is true. And in between, it is falses. If there's one of either, then it is false. So basically, we proved with this guy that if we can put it either way, my final truth table right here is logically equivalent to an if and only if statement. True, false, false, true. Okay, so if you see two trues, we count it as a true. If you see two falses, we count it as a true. And if it's anything else, it is always a false. So we're going to go ahead and apply that to a more advanced little truth table here. We're just going to do one big one, and we're going to practice some more in class. So we have P, Q, and R, and we actually need the not R version as well. So let's just go ahead and start filling out our truth table. If we have one variable, it would be 2 columns. 2 variables 4, 3 columns 8, so we have 8 columns this time. True, 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 false, 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 and we're going to go by 2s now because we're just trying to represent every different unique situation that could possibly happen, and then we're going to go alternate every single one, every other one. And if you can see any of these, they're all going to be different. There's not going to be any that match there, and that's why we alternate the trues and falses for our different scenarios. The not R is the opposite of regular R, so actually I'm going to label it backwards, false, true, all the way down. And then now I'm comparing P or Q. P or Q. As long as one is true, we're good. So I know the first 4 all have trues in them, so I know those are all true. And I see a true right here and a true right here. But on this guy, we got 2 falses, and on this guy, this guy we got 2 falses. Oh, whoa, 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 whoa. Looking at the wrong columns, Mr. Gillum. Okay, sorry about that. P or Q, we're looking at these first 2 columns here. Just label that for myself. P or Q, true, 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 true. And now we got a true right here, a true right here, 2 falses. There we go. Sorry about that. Having a hard time. Okay, now we're comparing P or Q to the not R. So now, you know what, let's just use a different marker so Mr. Gillum in his old age is not getting confused with himself. We're looking at those 2 columns. And remember now, we're going from anything that is a double true or a double false will be true. So a double true right there is good. A double true right here is good. A double true right there is good. And a double false right here is good as well. Everything else is false. It must be both true, true, or false, false. Otherwise, we are sitting false. Okay, so hopefully you know what a biconditional is. It's an if-then statement that works frontwards and backwards. And this guy's going to be important. Okay, true, true will get you a true output, and false, false will get you a true output. That's what we learned from proving what a biconditional is right here. True, false, false, true. And that's it for today. So hopefully you know what a biconditional is, and you can apply that to your knowledge of truth tables.